query optimizer. Now, what's the optimizer going to do? Well, the first thing it tries to do is rewrite your SQL statement. That gives us an opportunity to open up that SQL statement for additional types of join methods, join orders, and other things like that. If we're lucky, we may be able to eliminate some of the tables that are not actually needed in the join. All of that good stuff takes place there in the query transformation stage. Once we have the different versions of the query, we generate an execution plan for each one of those, and we apply a cost to each of those plans. Now, how do we do that? Well, we look at what resources we believe are needed to execute each of the operations in that execution plan, and then we assign a total cost for each of the plans. Based on that cost, we make the final plan decision, and typically we're choosing the plan with the lowest cost. That plan is sent to the code generator, who sends it over to the shared pool, and of course the cursor is created and your statement is executed. That process still exists today, so how do we make it adaptive? How do we make that a more self-learning exercise? Well, one of the things we could do is hold the decision on what the final plan is until we're actually executing it. How would you do that? Well, let's say we're looking at this SQL statement here. It's a simple join between the order items table and the product information table. And we're looking for what the number of products, or no, the product names for the products that we've cost $15 and that we've sold more than one of. Now, we have two possible join methods open to us here, a nested loops join or a hash join. Based on the table statistics we have today, the plan that we're going to go after is a nested loops plan. But we're not very confident in those statistics. Maybe they're stale, they haven't been gathered in a very long time. So we come up with an alternative subplan or an alternative option. And in this case, that option is a hash join. Now, the reason we're coming up with it as an alternative subplan and storing it in the cursor is to ensure that we don't have to hard parse again in the middle of the execution. So we make that decision up front, and then we insert something called a statistics collector in front of that first table, the table on the left of the join. And what that statistics collector is going to do is it's going to buffer the rows coming out of that table scan, and it's going to check to see whether or not our initial estimate on the number of rows coming out is good. If it's good, we'll just go ahead and continue with the nested loop join. But if it passes a given threshold, we're going to stop buffering and we're going to switch the plan and we're going to change to a hash join, because the number of rows really coming out of that table on the left-hand side, or the orders table in this case, is way more than we originally estimated it to be, and it's much more efficient to continue that as a hash join instead of a nested loops. So what do you see if you're now trying to tune this? I saw on Twitter in the middle of Tom's session somebody worrying about, I'm a developer, how do I know what plan I'm really going to get now with these fancy adaptive plans? Well, if you use explain plan before you execute a query that's going to result with a dynamic plan or an adaptive plan, you'll get the default plan or the first choice. So in this case, you'll see the explain plan showed the nested loops join, because that was where we were going to start this query. If we were to look at the execution plan after the statement completed, we would see the hash join, the final plan chosen for that SQL statement. What if I want to see both? What if I want to know if I've got one of these adaptive execution plans? Well, you can use a new format parameter to the DBMS xplan display cursor information, and it will show you the full and complete plan. You'll see there both the hash join and the nested loops in the plan, as well as the stats collector, which doesn't show up in the other plans in this mode. So in order to see that information, the new format parameter that I'm using there is +all_dynamic plans. I've also added an additional format parameter value there. I've added +adaptive. Now I've added that in order to get the additional information underneath the execution plan. That information is telling me exactly how to read the plan that's shown above. It tells me that the hash join on line 1 of the plan got actually enabled during execution, and the nested loops that are showing on 2 and 3 got disabled during the execution, and so the final plan was indeed a hash join between the two tables. Now, how do you know if you've got any of these kind of adaptive plans in your environment? There is a new column in $SQL. It's called isResolved Dynamic Plan. And what that's going to tell you, if it's marked yes, is that during the execution of this SQL statement, we had an adaptive plan, and we did actually resolve it or switch that plan during the course of execution. Once we've made that decision on that first execute, we no longer, we disable that statistics collector, we no longer buffer the rows, and we just go with that resolved plan for all future executions of that SQL statement. So we only do this buffering or this learning on that first execution. Now, there are some folks who are always nervous when Oracle introduces new features in the space of plans and queries, and Optimizer in general just makes them nervous. If this is something you're not comfortable having on in your environment out of the box, which is what's going to happen if you set Optimizer features enabled to 12.1 in your environment, you can disable this and by put it into reporting mode. And you do that with a new init.org parameter called Optimizer Adaptive Reporting Only. If you put it in reporting mode, what it means is, although we are keeping track of this information, we're not adapting any of the plans. So whatever the default plan was that we came up with at the beginning, that's the plan that we'll use all the way through the execution, but we will record the information if we would have switched. And you can see that information again if you use the plus adaptive format parameter in that DBMS X plan to display the plan. So just to recap, what are we talking about here with these adaptive plans? What we're talking about is the join method decision is being deferred onto runtime. It's just the join method, and we're going to be switching from nested loops to hash joins. That's what that means, and the way we're doing it is by creating these alternative subplans within the same cursor. So no additional hard parse is required to make this adaptive switch if it's needed. And we're making that decision based on the information that's going to be collected in these buffers or statistics collectors that will be inserted into the plan for you. Once we've made that final decision based on the information that's come in the statistics collector on the first execution, we'll use that same plan for the subsequent executions, and we'll disable that buffering. Yes, we have a question.
Did you ever go from nested from hash join back or nested loops in your?
So currently, the question was, is this one way only, nested loops to hash join, or are you also doing hash joins to nested loops? And the answer is in 12.1, it's only going to be nested loops to hash joins. The other part of the execution plan that we're also going to be doing this on-the-fly adaptation to is part of parallel execution. When you do or execute a SQL statement in parallel, that statement is being executed by multiple processes, and those processes need to talk to each other, and of course the query coordinator or the background process that initiated that SQL statement. When they are communicating with each other, they're typically distributing rows among each other, and Oracle offers a number of data distribution methods, and one of those is in 12.1 is going to be adaptive. It's called a hybrid hash data distribution, and what that means, just like before, we are going to be monitoring the number of rows that need to be distributed using the same statistics collector that we saw before. And if we realize that there are a lot more rows coming out, we're going to be able to switch the distribution method and change that on the fly. So let's look at an example here. We're going to join the departments table and the employees table. We're using a parallel degree of 4, but remember, most of the time if I've got a parallel degree of 4, I actually have 8 parallel server processes executing my query, right? 4 producers, 4 consumers. Those producers are the blue boxes there, P5 through 8. They're going to begin the scan of the smaller table in this hash join, and they're going to scan the department table. But they're not going to instantly send their rows to the consumers. We're going to insert that statistics collector in front of those processes, and we're going to buffer those rows till we see whether or not our initial estimate, which was a small number of rows coming out, is actually correct. If we have a large number of rows coming out, if that's not actually correct, when we have a lot less rows coming, we're going to switch from a hash distribution to a broadcast, and broadcast those rows into all of the consumers instead of hashing them on the join key to the consumers. Once that decision has been made and the switch has happened, those processes move over and then they start to scan the employees table or the second table in the join. The distribution method chosen for that table is dependent on whether or not we went with the switched mode, which was broadcast, or whether we stuck with the original decision of hashing the rows to the consumers. So if we changed on the department to use broadcast, then the employees table would do the data scan there would do a round robin distribution. If they stuck with the hash on the employees, on the department table, then the employees table would follow suit and we would also do a hash distribution there. How do I know in the plan if I'm going to be using this hybrid data distribution? That information is shown in the execution plan, both in the operations column and in the PQ distribution column. You'll be able to see hybrid hash being used. That's that new distribution method being used. Okay, so that sums up what is going to be done at execution time with adaptive execution plans. We may switch the join methods and we may switch the data distribution types. But a lot more other decisions are done on your behalf by the optimizer when we're coming up with that execution plan. And the majority of the information we're using to make those decisions comes from statistics. It comes from the base statistics you've given us about the objects that we're going to be running that query with. But sometimes those base statistics are just not enough. Sometimes if you're using an extremely complex predicate or multiple joins and joining the two tables together, the base statistics may not be enough. And what if we were able to do more dynamic statistics at parse time in order to get you a better execution plan or more information? And that's what's going to happen with the introduction of dynamic statistics. Dynamic statistics replaces what was originally called dynamic sampling in previous releases, and it gives us the ability to find out more information about the objects and about how the where clause predicates that you provide affect the rows within those objects. The decision to use dynamic statistics is based on the complexity of your query, how long we think that query is going to run. And the advantage of dynamic statistics over the old dynamic sampling is that the information recorded during one query is now stored and can be shared among other queries. So let's look a little bit about how that would work. Say we're doing a complex query against the product information table. I'm looking for products that have a list price of 29 but are not in either of these two popular categories that I've got, and the product name has the word smart in it. So several single column predicates going on there. All of those predicates do have some kind of a relationship. But when you submit that query, the optimizer is going to check what statistics do I have on the product information table. It does find statistics on that object, but with those complex predicates, those statistics may not be enough to get us an accurate cardinality estimate. So the optimizer is going to engage dynamic sampling. It's going to use the new level that Tom talked about in his session earlier on. And it's going to record, or it's going to gather information about how those where clause predicates affect the rows in the table, the product information. Once we have that information is going to be stored now in a new area in the cache, and that way it can be used for other tables that other queries that are going to use that table with those predicates. Based on the information we find as part of that dynamic sampling, we're going to come up with the execution plan, and that's what we're going to go ahead and execute. Now let's say a second query comes in on the product information table. It is the same where clause predicates, but it's looking for different information within the table. Again, when the optimizer sees that query, it's going to check what base statistics do I have. It finds those. They may not be enough in this case. And so it goes and uses the dynamic statistics that we've already recorded in conjunction with those base statistics in order to come up with the best execution plan for the SQL statement. Now, since that information is stored in the cache and not persisted to disks, it will age out if the system is shut down, and so we would have to redo it. But for the lifetime of this instance, that information should be there, and it should be used by the other statements that are coming in and out. Yes?
So whenever you have their uses literals, what happens
So the question is, your example on the slide is showing literal values in your where clause predicate. What happens if the SQL statement comes in with binds? Would you share the same dynamic statistics even if the bind values were different? That's what you mean?
It doesn't share.
It's
not based on the exact same predicates.
Correct.
So
Bind is part of the sharing condition.
So just in case you didn't hear it, that no, we would not share if the bind values were different. They are part of the sharing criteria, and so if you came in with a new set of binds, we'd find new dynamic statistics for you. Yeah. So the question is, what is the impact of dynamic statistics on larger objects, or objects that have got hundreds of rows? So when we're doing that dynamic sampling, we are looking at a small number of blocks from those objects. The size of that sample is decided automatically for you, but we're not scanning the whole table looking for this information. We are just looking at a sample and then extrapolating what we think will be for the whole table. What you're asking, what is the error rate of that? So the question is, what if you've got a lot of skew in the data? If you're only sampling, what is the error rate you think, or the impact of the skew on the results?
Answer? Yeah. The way this information is used guarantees that it cannot be worse than what the estimate by default is. So for example, if the estimate without using dynamic statistics, let's say, is 5, and if sampling came with a number, let's say 10, then the number that we guarantee that it cannot be less than 10. It can be more than 10, for sure, right? Does this answer your question? It puts kind of a sanity check on the number that Optimizer come up with. We compare that to what sampling query says, and then if the sampling query comes up with a higher number, that number is definitely as a minimum.
So it's not a silver bullet.
There is no silver bullet.
Yeah.
So, if I understand you correctly, basically each set of values come into, basically going to have like a separate entry. Is there a way to control how many entries we keep for?
Why do you want to control that? Why do you want to control that?
I'm just asking that.
So the question is,
there's no way to control that.
there is a cache where this information is stored, and the question was, can I control what entries are in there or how many entries are in there, and the size of the cache, and the answer is no. Okay, so as I said, we're going to use these dynamic statistics to compensate for...
Can I just roll up on the question? So the cache is an optimization, like in some sense, right? We just have a fixed size cache, and that cache is aged out if the information is... No. Make it easy for you.
So as I said, these dynamic statistics are going to be used to both compensate for missing as well as stale or incomplete statistics if we get these complex queries coming in. They can be used for to determine the access methods as well as the join types. As somebody asked earlier on, what is the size of the sample and all of that good stuff? It is determined by us automatically. We are given a budget for how long, based on the complexity of the query, we should take to do this and gather this information. And as I said, they are stored in memory so that they can be shared across the other queries that are on the instance. But if that instance does go down, that information is lost. Okay, so we can improve the statistics. We can make some of the decisions now dynamically during the execution. What happens if we learn more information during that execution? Isn't there a ton of stuff that we learn as part of an execution? And there is, and we want to be able to feed back that information. So we may not be able to adapt the plan on the first go-round, but once we learn that additional information during execution, we should be able to put that information to good use. And this may sound familiar to some folks because this next section, or re-optimization as we're calling it, this next part of adaptive statistics, is based on cardinality feedback, which was introduced in 11G-R2. And what it's going to allow us to do is to compare the estimates that the optimizer comes up with during the plan creation to the actual number of rows returned by each of the operations in the execution plan. If those numbers vary drastically, we're going to be able to re-optimize on the next execution using the information we learned during the first execution and come up with a better plan. So let's talk about how that works. As I said, this was, let's say, the big brother to cardinality feedback that was introduced in 11G. And with that, we were only looking at single table cardinalities, and that's where we're going to have a quick look at an example here. Let's say this is our query. We're joining the customer and the sales table together. On the initial execution, we originally estimated a very small number of rows were going to be coming out of the customer table, just one, and only 5 rows would be coming out of the sales table. Well, the actual number of rows returned by each of those objects was a lot larger. Over 8x difference between what we originally estimated and what actually came out. So what do? Well, on the second execution of that SQL statement, what we're actually going to use is those statistics we learned during the first execution instead of the base statistics. And it's going to give us a much more accurate estimate of the number of rows that are being returned by each of the operations. And it's going to give us a different execution plan. Based on that, we decided to flip the join order and get a better execution plan for our SQL statement. Now, in the initial version, in this example where we're doing cardinality feedback, we were doing it, like I said, for just single table cardinalities, and the information that we learned was being stored in the cursor in the shared pool, which meant that subsequent executions of that same SQL statement could learn or use that information. But if that cursor aged out of the shared pool, we lost that information and we had to learn it all over again on the next execution. So what's different in 12c? Well, for starters, the information that we learn as part of the reoptimization is now being persisted on disk in something called the SQL plan directive, and I'll talk more about that in the next section of the presentation. But we're also going to be able to use this reoptimization approach in other cases. Things like joins, we're also going to be able to use it with statements that have binds, which was a limitation of cardinality feedback in the previous version where it was only used for literals. How do I know if I have any plans that are needed reoptimization? Well, there is a new column in $SQL. It's called is reoptimizable. After the first execution, if we are planning to reoptimize or reparse the SQL statement on the next execution, that column will be marked yes. So that means this statement on the next execution will be reparsed using the execution statistics we learned on the previous execution and to come up with a better plan. Okay. Now, if we looked at the original plan that we had on the, oh, sorry, there's a question. So you're saying it's fine when there's only 2 tables in the join, but if you've got 7 or 8 tables, the number of possible join combinations is quite large, right? But what's the question?
Then how many plans are you actually storing in the SBA or storing off? Because there's really multiple plans that can be gone. I've seen this in Tennessee, will not work, or be allowed to not work. That feature for the adaptive plan. Where the existing order is done in 2 seconds, and the adaptive plan takes 4 seconds. And so I'm just wondering, how does you said you have 2 plans with 2 tables.
Can you repeat the question?
So the question is, if you have a complex statement where you have like 10 tables being joined, you have essentially like 9 joins, right? So the question is, how many plans are you going to go through before generating that, right? This is correct, right? There aren't as many plans as you think in terms of, even if you correct, like in the first pass we correct all the single table cardinalities, right? And we correct all the joins that we have picked in the first plan, right? In the second iteration we correct only the things that have been not seen before. So it's cumulative, right? The first iteration the information collected in the first iteration are carried over for the next iteration and so on and so forth, right? So the information is not lost from one plan to another. And then the number of plans we generate is bound. There's a limit of how many plans we generate because of the optimization.
Okay, so if we go back to the original plan that we had, the original SQL statement that we were looking at for the adaptive execution plans, that join, remember, between the order items and the product info. If we had looked in $SQL for that, not only did we realize it had a resolved dynamic plan, so on the first execution, we had switched from the nested loops join to a hash join, we'd also noticed that it had also been marked is reoptimizable, which means that on the statistics that we found, the estimates were way off from the actual number of rows returned for that query. So what does that mean? Well, it means that we're going to re-optimize that SQL statement if it's executed a second time. We're going to use the information or those execution statistics to come up with a better plan. And in this case, on the second execution, we have a new plan, new child cursor is created, and we see that not only did we switch to a hash join, we also changed the join order. Something that we couldn't do as part of the dynamic plan, we're able to do with reoptimization, and we're able to switch the join order on that. How do I know that I'm using reoptimization? Well, you can see it in the notes section of the execution plan there. You see cardinality feedback was used for this statement. Yeah, there's a question.
So to be able to have this feature, for example, we have a battle line, where it's still running. If we kill that, you lose all the data, or you need to complete the full plan before you have it.
So the question is, if I have a really bad running SQL statement, I'm more likely to kill it before it actually completes execution than to let it run to completion. So do I lose all of this information if I kill a statement midway through?
The answer is no. We carry the information we learn up to the point when the statement was killed. So we harvest all the information we had collected during that execution up to the point where it was killed. And then when you re-execute again, that information is reused as part of the feedback process.
So if you have poor query because of your customers, as for you run, you learn.
Correct.
When you kill it, you will rerun, the plan will be able to click with it.
Correct. The plan will be re-optimized. The statement will be re-optimized. And by the way, just to follow up the earlier question, I think there was a concern about the SGA, like how many statements we're going to start in SGA. Actually, we don't. The earlier plans or the earlier cursors we have built are marked as not reusable, which means they will be purged out of the shared pool when the memory is needed.
So the question is, what happens if the original statement has a hint in it?
What's the concern? If you have hints, then you obey the hints, right?
So,
Go ahead.
no, we are forcing the execution plan to be a hint. Now, is the optimizer going to replace those hints?
No. The hints will be obeyed. It's just the calculation of the cost and the cardinality will be more accurate. Which means that we obey the hint to the extent where the hints are specifying what needs to be done. But chances are, when you specify hints in a statement, you are specifying hints for some of the things of the statement, right? You don't specify hints for everything. Unless you copy and paste the outline of the statement, the hints are open-ended, they are partial, right? So the other options that we have to make choices for, this estimation of or this feedback is useful for those statements, right? If you have a plan baseline, then those estimates are used to correct the cost and the cardinalities will be used to find an execution plan that we didn't know about before. So the idea is, talking about it like in the context of SQL plan management, actually you have to repeat the question.
So yeah, so what the question is what if I have a SQL plan baseline that is the plan that I want, but you're doing this stuff, or you're finding this information? So
yeah, so the answer is, if you have a SQL plan baseline in a statement, we obey the SQL plan baseline, but we still allow the optimizer to find alternative plans. These alternative plans will be verified as part of the evolve process of SPM to see if the new plans is better than the old plans you have as a baseline. Does it make sense?
yes,
No,
so yeah, if you're SQL plan management and you've explicitly
yes,
marked it as
correct.
fixed, you're right. We don't capture additional plans for that SQL statement. So you're right, you would lose it in that case. So stay tuned. The question is on SQL plan management and evolving plans. Stay tuned. There's more of that in the presentation. So we'll wait one more question, then we got to move on. We're running out of time.
Is there a way to see what the adaptive statistics in that regard, perhaps to get those versus the regular statistics to see where there's gaps?
So the question is there any way to see the execution statistics that are being captured or the dynamic statistics that are being generated? I am not aware of a view. Are you?
I think there is, okay. The statistics collected as part of the execution of the statement, they are not the same thing as the base statistics collected as part of the DBMS stats package. Is this what you're trying to refer to? They are different. They are not the same. The statistics collected from the DBMS stats package are, statistics about base tables, like, number of rows, number of blocks, number of distinct values of columns, min-max, and so on and so forth. The ones we collect as part of the execution of the statement for reoptimization and for adaptive execution, they are more about intermediate results. Right? Like, what is the output of a join? What is the output of a table scan with some filter predicates? What's the output of a group by, and so on and so forth. The distinct Right? They're not about base tables, so they're not comparable. But
Okay.
if you want to see the output, you can look at them using SQL report, or you can look at them if you gather statistics as part of the hints. I mean, there's like all the examples in the slides show the hints called gather statistics, and that we allow you to see the actual rows estimated. I mean, estimated rows are the actual rows produced by every row source. So this is what the optimization is doing, is to compare those numbers.
Okay, so as I said, with this new re-optimization, how it differs or is a grown-up version of the cardinality feedback is the information that we learned during that re-optimization is now persisted on disk and can be used not just by this query, but other queries, and it's stored in the form of a SQL plan directive. Now, directives are additional information that we are going to use during the optimization of this SQL statement or others that share similar SQL phrases, so or query expressions. So what we're doing is, instead of storing it tied to a SQL ID or a SQL handle the way a baseline is or a profile is, we're going to just do it on a SQL phrase. So in this case, in the example, I'm saying that if I'm joining table T1 to T2, I want you to use dynamic statistics in this case. Don't rely on the base statistics for that. Any query in the future that is joining T1 and T2 together is going to be able to take advantage of that SQL plan directive and to use dynamic statistics instead of relying on the base statistics, not just this one query. Now, the SQL plan directives are being persisted in the sysops table space. They are automatically created for you, and we will automatically maintain them for you. If there are SQL plan directives that have not been used for 53 weeks, we'll automatically purge those out of the sysops table space for you. There is a package where you can manage some of this stuff, and I'm going to show you some views in a moment. Sure, we have a question.
Is there a way to correct those statistics preemptively to save effort at runtime?
So the question is there any way to preemptively create these SQL plan directives yourself to reduce the overhead of runtime of having to find them? The answer in 12.1 is no, that it is all automatically done for you. So let's look at an example. It might be a little easier if we do about how this goes on and how they're going to be used. So in this case, we've got a pretty straightforward query against the customer's table. It has two where clause predicates. One is on state and one is on country. First thing, when that statement is presented to the optimizer, it looks at the base statistics. We have accurate stats in the customer table, and it comes up with an execution plan based on those stats. Now, during the execution, we realize that the actual number of rows being returned by each of the operations in that query is actually a lot more than we originally suspected. So that cursor is marked is re-optimizable. Remember, that's cardinality feedback or re-optimization kicking in. And you'll notice that a directive has been automatically created in cache for that. That directive says the next time you see the state and country columns being used together in a query with on the customer table, use dynamic statistics. What does that mean? Well, it means that the next time that SQL statement is executed, the optimizer is going to use the execution statistics we learned on the first execution, or that we got at a cursor 0, to come up with a new execution plan. That new plan is created in a separate child cursor, cursor number 1, and this execution and subsequent executions are going to use that plan instead. Now, those directives are periodically flushed to disk every 15 minutes and persisted in the sysops table space. When a new query comes in on the customer table, different query, but it does have the same two columns in the where clause predicate. This again, state and country are being used. When the optimizer sees that SQL statement coming in, it's using the base statistics, but it also checks to see whether or not it has a SQL directive for that new statement. We find the SQL directive that says you should be using dynamic statistics when state and country are used together, and so the optimizer uses dynamic statistics at this point and comes up with an execution plan based on those dynamic statistics. Now at this point, you may be wondering, well, why haven't you used extended statistics? In 11G, you banged on about all these extended stats that you'd introduced. Why didn't you use extended statistics in this case? Well, we're smart enough to realize that the problem that we're having with the cardinality estimate could have been solved by extended statistics. And so we make a note to add a new column group to the customer table on state and country. So the next time you gather statistics on the customer table, we will automatically create the extended statistics on state and country, and those statistics will be maintained every time you gather stats on the customer's table. How do I know if these SQL plan directives are being used in my queries? Well, if you look in the notes section of the execution plan, just the way we show you that a SQL plan baseline was being used, you'll see a SQL plan directive was being used for this SQL statement in that notes section of the execution plan. Now, there was a question earlier about could I create them in the directives. You can't create the directives yourself, but you can see what directives exist in the database. There are two new dictionary views for that, DBA SQL Plan directives and DBA SQL Plan dir objects. These views give you information about what objects have directives and what those directives actually are. So each directive is given a unique ID, directive ID. You'll see there who owns them. The first one, I have two here. These are based on the ones that we saw in the examples, the directives that would have been created on the examples we looked at earlier. First one is on the customer's table in the SH schema. And what it's telling me there is that there's an issue with the single table cardinality estimates. In this case, it's the customer's table. And it's telling me that I should be using dynamic sampling or dynamic statistics for this statement. The second directive is part of the order entry schema, and it's on the order items table. Again, it's a single table cardinality misestimate, but there could be others. It could be a joint cardinality misestimate. There can be other reasons for it being created. And again, in this case, it was on quantity and unit price are the two columns that are involved in this directive. We had a question.
Could you use reapplication testing to actually preemptively use some of these things like capture merge estimates, running as well a few times so that you actually build all the directives in advance of me going on?
So the question was, couldn't you take advantage of real application testing or the RAT option to either capture your workload and execute it a bunch of times on a 12 environment to ensure all of these things were created, or the directives were created and in place for me before I went live in the environment? Yes, you absolutely could. There's absolutely no reason why you couldn't do that.
You can also use SPA, SPA.
Yeah, the SPA part of the RAT option, yeah. This lady had her hand up first.
It's not very significant.
So the question was how there's a lot more things being stored in the SGA than there ever was before. Do I need to bump up the amount of memory I allocate to a 12C database versus an 11 database? And although Mohammed said the amount of memory we're using is very small, everybody knows when you upgrade from one release to Oracle and another, you do need more memory.
My answer was not because of this. You can increase it, of course, but I'm not responsible for it.
So the question was, what if I'm in a rack environment and I learn this information on just one node? How do I make sure that the nodes on the query, if I issue the query on another node, that information gets passed over?
It's flashed to disk. Dictionary is shared across all the nodes. So.
Really quick, because I'm rapidly running.
Very quickly, how does this interact with that first?
So the question is, how does SQL Plan directives interact with adaptive cursor sharing?
It works.
There you go, folks. You heard it from the horse's mouth. It works. You're good.
Ask a short answer. Short answer.
There you go. Thank you.
Quick question, right?
Yeah. In the interest of time, I'm going to keep moving. Now, you'll also see that each of these directives, or each of the SQL Plan directives, has a state listed there. Okay, whether it's new, and in this case, one of them says it's missing statistics. This is from the example I just showed you, that we were able to realize that the directive was in place because there were multiple single column predicates being used on the customer table, and that extended statistics would have been a good way to give us that same information. So rather than spending all of this time at execution, as one of the audience members pointed out, we are able to create those extended statistics automatically now. So the next time you gather stats on the customer table, we'll automatically create the column group for you, and we will maintain that column group on every time you gather stats on that object thereafter. So here, all I had to do was just gather stats on the table, and then when I look in DBA stats extensions, I can see the column group was automatically created for me. Then what you see in the SQL plan directives is that it has stats. What that means is we're pretty sure we're not going to need this directive because we have extended statistics in place. If the query comes in on those columns is an equality, we'll be able to use those extended statistics. If it's a non-equality, then we may need to go back and use the directive. Okay? And in this example, because it was equalities, you don't see the directive being used anymore. You actually see us getting the correct cardinality estimate straight up front, and we have the extended statistics in place. So, okay, so.
I have a comment before moving to the next topic. Just, there was a question about can we proactively create those directives? You cannot manually create them, but there are two types of directives. The one that results in creating extended stats, and there are the ones which results in using dynamic sampling. The one that results in creating extended stats, you can proactively create them. There's a PSQL function called seed column usage and DBMS stats. And that one allows you to create extended stats even before running the queries. You can just do explain that using like an STS, a SQL tuning set.
Yeah. Oh, I love this question. Is everything that I've seen today a licensable option, or do I have to pay you more money? So,
yeah, to me.
being the European socialists that we are, we say, no, you don't have to pay any more money. It is, okay, yeah, so it's part of Enterprise Edition, but there is no additional licensing required. Why would you want to turn it off? So,
as part of socialism, you cannot refuse it. You have to leave the country.
Okay, so in summary, what are we introducing with what we're calling adaptive query optimization, or our first baby steps towards a self-learning optimizer? We have those adaptive plans. Remember, that's changing the join method or the parallel distribution method as part of the execution. We've got adaptive statistics, which we can change at compile time, that we're learning at compile time or at runtime, feeding those back in and coming up with better execution plans. But that's not it, right? There's still lots of other pieces of information that the optimizer is using and that is going to continue to use, and they are statistics. With every new release with Oracle, we try to provide an additional statistics and information to the optimizer in order to get the better execution plan straight away out of the box without having to adapt. And just with each release in 12c, there are a lot of new features in the statistics area. If you guys have been to some of the other sessions this week, you might have heard mention of some of these. I know Jonathan did a great session on Monday all about the histograms. We don't have enough time to get into any of these really, but I'm going to try and do some quick highlights. I'm going to skip through the histograms because Jonathan talked about those, but I will just say that there are two new types of histograms in 12c, top frequency and hybrid histograms. And you're actually able to see some of them in action in just the sample schemas. So if you are looking in 12.1 and you wanted to see what's going on, you can see those. You can see them in the sample schema, as I said, in action. So I'm going to skip over those. I'm going to talk about one of the other ones that hasn't been. Oh my goodness, I have lots of bills.
Nobody's taking pictures.
Okay, I wanted to talk quickly about some of the other features in the stat stuff that may not have been as well highlighted in the other sessions. First one is online statistics creation. For a long time, you've been able to create an index and automatically have statistics gathered as part of that create. We now have that for create table as select. If you do a create table as select, where we have the information about what's going to go into that table, we're able to piggyback that initial scan and gather statistics on the data so that as soon as the table is created, we have stats for it. We're also able to do it for an insert as select, as long as the object we're inserting into is empty, so that we're just piggybacking the stats gather on the select part of those statements. Remember, they are both direct path operations, so it's only going to work for direct path operations. It isn't going to work if you're doing single row inserts. But just a quick example that you can be able to try yourself. Here, all I did was I did a create table to select from the sales table in the SH schema to create a new table. And you can see there, that was the time stamp that I started on. I ran it, and instantly I have statistics, both column level stats as well as base table stats for that new table I've just created. The other place where we've made big enhancements is in global temporary tables. This has been the bane of a lot of folks' existence. If you have lots of sessions that are using the same global temporary definition, or global temperature table definition, but have very different data sets in each of the sessions. In the past, even if you could gather stats on that, all of the sessions shared that same set of statistics. In 12c, out of the box, each session will have its own set of statistics for the global temperature table. So when you gather statistics, it'll just be for your session. It won't have to be shared by all the others, but you can, if you really want to, switch it back and have it in a shared mode if that's what you want. And it is controlled by the DBMS stats preferences. There is a new preference called global temperature table stats. By default, it's set to session, which means that the stats I gather are just for me. If you want to set it back to the old behavior, what you had in 11 or previous releases, you want to set it to shared. Okay, so as I said, there are a ton of new features in this space that all should hopefully help you get better execution plans for your SQL. There's the adaptive execution plans, there's the adaptive statistics, and all these new enhancements to the base statistics so that you can be able to give us more information. But that's not it. There are a ton more other features that we just don't have time to talk about in today's session. We've got improvements to a lot of the existing functionality that people are just starting to use in 11, things like incremental statistics and concurrent statistics gathering that we talked about at last year's Open World. More information on that is in the stats best practices white paper. SQL plan management, which the young lady who was asking that question has disappeared. We now have an adaptive plan evolution in 12c. What that means is that we now have a new nightly job that will look for unaccepted plans in your SQL plan baselines. It will do the evolve testing on those. If those plans prove to perform better than the existing plans, they'll be automatically accepted. If they don't, they'll be the date on which verification took place will be marked down on those statements. On those plans, and they will not be test evolved again for at least 30 days, and only then if that statement is active in your environment, one that you're using all of the time. So, but there is that new nightly job there, so you no longer have to do the evolve yourself. And of course, there's always a ton of new transformations going in. We're always trying to improve the plan options that we give the optimizer before we execute the SQL statement. So with that, I'm going to open it up to questions. I'm sure there's a few more in the room. I'll do my best to repeat those questions. I don't think we have a mic. Oh no, there is some mics in the room. So if you can, it would be easier for us, especially if you're sitting down the back, to go to a mic and ask the question there. But other than that, I thank you very much for your time, folks.